Hello, this is Hank Green for SciShow. We're doing a new thing. You can tell because I'm sitting down, which I never do. We're actually going to be interviewing a scientist by Skype because, as you probably are, we are very excited about the New Horizons mission, which, as of the time of the filming, is flying through the Pluto system right now. But by the time it will be uploaded, it will be through. But we've been able to steal away a scientist from their very important work. This is Dr. Alex Harrison Parker, who has been working on the New Horizons mission for a few years, and we will get to learn some of the fascinating things that we're hoping to find out and some things that we have already found out. I'm very excited to welcome to SciShow Dr. Alex Harrison Parker. And where are you right now?
I'm at the Johns Hopkins University Applied Physics Laboratory in Maryland, where the spacecraft itself, the New Horizons spacecraft, was assembled, and where the Mission Operations Center is and where the science operations are ongoing as we go through Flyby.
So this is like mission control for New Horizons.
Yeah, we're calling it Pluto Central out here right now.
That's pretty cool. So how long have you been working on the New Horizons mission, and what's your role there?
So I came in during the end of my graduate career. I started working on the search for a post-Pluto target. So New Horizons is a flyby mission. In order to get to Pluto in a timely fashion, we basically built the smallest spacecraft that we could and put it on the biggest rocket that we could get our hands on. So it bulleted out across the solar system in 9 years. And if we wanted to stop and go into orbit, we'd have to have carried basically as big a rocket as the one that we launched with us the whole way, and that was a bit impractical. So we're doing what we've done with a lot of the first reconnaissance of the solar system, doing a fast flyby to try to get a first glimpse of the system, do as much science as quickly as possible. But then after Pluto, we haven't used all the fuel in New Horizons tanks, so we can do a small course correction as we go further out into the solar system and fly by a more distant object in a few years' time. But at the time of launch, we knew that we wanted to do this, but we didn't know of a place we could send it. So we knew that there were objects out in the Kuiper Belt and that there were probably enough that it could reach one, but a survey had to be done. And so one of my specialties in graduate school was developing tools for finding faint moving objects in front of crowded star fields.
Okay.
And the real challenge of the Kuiper Belt search was that the objects that we were looking for post-Pluto mission were not just anywhere in the sky. They were in a very specific region of the sky, and they were deep in the Milky Way, where there are millions of stars in the background. So it's looking for a needle in a haystack, really. So they brought me on board as a remote specialist, where I worked at Harvard and then Berkeley on this project before last year coming to Southwest Research Institute in Boulder to join the core team. So I've been working somewhere between 3 and 4 years on the project. So now I'm part of the core flyby team, and I'm working on the Pluto flyby that's occurring, closest approach occurring tomorrow. And then I will be returning to working on the extended mission proposal, asking NASA to support this post-Pluto mission, where we'll retarget in October of this year to fly by a more distant KBO, probably in early 2019.
Cool. So you basically, New Horizons is headed in a direction, so you have to find something that's roughly in that direction, and you do minor course corrections to hit it.
Yeah, it's a very small correction. The amount of fuel that we have left is not a lot, and the speed of the spacecraft is a lot. So I think the number that we worked out roughly was about a half a degree change is what we can make in the trajectory. So it's a real narrow tweak. So this was a real challenging problem. We spent a lot of time on some of the largest telescopes in the world, Subaru in Hawaii, the Magellan telescopes in the Southern Hemisphere in Chile, Canada, France, Hawaii telescope, a few others. And we spent years working on this, but the crowded star fields, all these stars in the background, and the temperamental nature of Earth's atmosphere made this a really challenging proposition. And we found a lot of Kuiper Belt objects in the right area of sky, but none of them had precisely the right orbits for us to be able to reach them. So last summer we went to Hubble. We asked Hubble for quite a large amount of time to go do this survey. And the reason why we held off on using Hubble is because it's a relatively expensive operation. Hubble's field of view is very small. And so if you want to cover a large area of sky, you have to do a bunch of small visits, and that takes a lot of time. So last year was the only year that it was practical to do this with Hubble. Before, we would have had to search more sky and would have taken longer. After, we wouldn't have enough time to measure the Kuiper Belt object's orbit sufficiently well to target the spacecraft to reach it. So 2014 was the year, and we succeeded. So we performed what amounted to basically the fastest, largest survey for slow-moving objects with Hubble that has ever been performed. And We got 2 candidate objects that have the right orbits for us to be able to reach them, and we're right now in the process of refining their orbits, trying to understand their properties and make a selection as to which we'll target. We can't target both. They're kind of on the opposite sides of the cone. So we can pick one and go very close to that. We can do long-range observations of the other one and several others of these objects that we found, but we're going to get one where we fly up very close.
So you're basically looking at star transits then. You're looking at like the dimming of stars in the sky. That's how you're finding these objects?
No, so what we had to do, and that is a legitimate way to search for Kuiper Belt objects. That's called the method of serendipitous occultations, and that has been attempted for many years. And there are 2 claimed detections of Kuiper Belt objects through that method from the Hubble Space Telescope. What we're using is direct detection. We actually need photons from the sun to propagate all the way out across the billions and billions of miles of the solar system, bounce off one of these objects that are as reflective or less reflective than asphalt, travel all the way back across the solar system, reach our little piece of glass, and be collected by a detector. So, the objects that we were looking at are some of the faintest objects that have ever been seen in the solar system. They are very small, but so they're tens of kilometers across, and they're extremely far away. And so that makes them incredibly difficult to image directly. But there is no better way at this point to find objects in that size. There are mission proposals to do to use the occultation method to find many Kuiper Belt objects, but the downside of that is that you only get one observation of any one object, because it'll only, by chance block out a single star. And so you'll know roughly how far away it is and how big it is, but you won't be able to predict where it'll be in the future. So there's a mission proposal called Whipple. It's a large mission. It's about the size of the Kepler Space Telescope. They would go out and do this wholesale and measure the sizes and distances of many Kuiper Belt objects and tell us about the formation processes that made these objects by measuring this size-frequency distribution. And I've PI'd a proposal for a much smaller, basically a CubeSat, that would do the same thing on a smaller scale. And those are both out for consideration right now.
Cool. I should just ask first, like, how is it going there? Like, how do people feel? Like, are people sleeping? Is there a lot of energy?
The idea of doing a Pluto flyby goes back to the 80s and before. And this particular idea, the New Horizons mission, has been around for a very long time. And so there are people who have been part of this project, namely the PI Alan Stern and other members of the so-called Pluto Underground that were pushing this concept in the late 90s and early aughts. And a lot of them are still here. A lot of them are the team leads and the deputy PIs and the instrument PIs. And then there's a lot of us that came more recently. I'm an early career scientist, and there's a lot of us on the team. There are postdocs and young research scientists that are working on this. I'm not old enough to remember the Neptune flyby, and there are a lot of us on the team that, for us, this is the first time we've encountered a new world like this for the first time. And so, for those of us that have never done this before, we heard from those that were around for the Voyager days what that was going to be like, the kind of build and the kind of energy, and it was really hard to internalize that. It was really hard to take what they were telling us and be like, this is how we're going to feel once we get close, and predict that. So we're going through these exercises, we call them operational readiness tests, in which they provide us with sort of synthesized data, and we have to test all our tools and processes and schedules to make sure that we can deal with the flood of stuff that's going to be coming back in real time. And it was very difficult to actually get engaged with that. It was kind of cool, and it was fun to make sure things worked, but the emotional aspect wasn't there, and the degree of engagement that we would feel when the real thing was there. And now that we're getting that stuff back, the stuff we've been seeing today, and the stuff that we've been sharing with you all, the last few weeks, and the stuff that we're going to be sharing over the next couple days, it's unbelievable. And people are sleeping, probably not enough. And whether or not that's gonna continue, tonight's gonna be a really unbelievable night, and tomorrow night as well, in terms of the stuff that's coming back. We're gonna hear our last communication from New Horizons will be later tonight, before it goes into the autonomous flyby mode, in which it drops contact with Earth and is basically too busy to talk. It's just taking science full time, and it will come back into contact tomorrow evening and send home the "I'm all safe." And so in that time, we're going to take the data that we have and do everything that we can with it, and just wait and hope that everything goes well, and we'll know tomorrow night. So I think there's going to be a lot of jitters and nerves and excitement, and people trying to understand and predict what we're seeing, are going to see, given what we have seen, and it's just totally wild.
Is there anything that's been surprising to you so far from the data you've received?
Yeah, so my background is largely in, I have an astronomy background and planetary astronomy, and I have some degree of dynamics in my background. So I've studied like planet formation and evolution of binary systems in the outer solar system. And so one of the things that's always fascinated me about the Pluto system is it is a packed system of satellites, right? It has all these small moons and then this massive moon. It's the only binary planet that we know of. And just basically every time we looked at the system better with Hubble, we found more moons. And so the expectation, and this is what led to the whole hazard search, this process of using Hubble and then on approach using the long-range imager on New Horizons to search for the small moons, because these small satellites themselves, they don't present a challenge, but basically they're small enough that if you blow debris off of them, it can hang around for a while in the system, and it doesn't take much to cause damage. It's about something about the size of a rice pellet at the speed New Horizons is going could potentially cripple the spacecraft. So we really wanted to understand if there were other sources of debris in the system that could be producing debris across the swath of space that New Horizons was going to fly through. And we searched and searched and searched, and nothing was turned up. So at this point, we can see things that are much, much smaller than the smallest known moons of Pluto, and we haven't seen anything. And so some of us just had this sort of intuition that given that every time we've looked harder, we found more, that it would just be this sort of scale-free thing. We'd get closer and we'd see maybe a debris belt or smaller moons or co-orbital moons, things that are sharing the orbits of other moons like we see in the Saturn system. None of those have turned up. So that's a little bit puzzling, and maybe that was just a bias on our part coming in, that this is kind of how it's gone with other planetary systems, and we've seen so many in the Pluto system. The dark pole on Charon is such an interesting feature, and right now we're trying to understand whether or not there's topography that goes along with it. Is it a spot that's just painted over the local topography? Is it some kind of a depositional film, or is it actually we're looking at something like a basin that was created by a massive impact, and perhaps Charon reoriented because it was structurally damaged so much that the gravitational field made it prefer an orientation with that pole up? It's too early to say, but that's just one of those things that we saw it and we're like, that is such a striking feature. And then, we're on the edge, just on the resolution edge of being able to say so much more about the surface features on Pluto. And there's so many in this, the scale on which they are apparent across the surface. We have these global structures, these annuli around the pole that appear to have just globally different features. But then you get closer and there's these smaller structures that are coming into view and hints of topography. And it's I think if we'd been on Voyager, like I'd said, if we'd done one of these flybys before, we wouldn't be surprised by this sort of feeling of, oh, we're almost there all the way through. But for the younger scientists that are on the team that have never experienced this kind of a flyby before, this is a totally new and surprising process.
It's fantastic. That's really exciting. Is it cool to have? Do you get the sense that the rest of the world is there with you, sort of? Maybe not biting their fingernails the same way that you are, but do you get the sense of that excitement?
Yeah, it's interesting to see people coming on board, and it's easy to tell sometimes because we'll tell essentially the same story and we'll get the same questions. And so these people are picking up the story as it goes along. And so we're trying when we're writing up the things that we're releasing, the stories as we're telling them, which will get more and more detailed, to make them all stand alone, because we're recognizing that we don't want to have, we don't want this to be a thing that you have to go back and read book 1 to understand book 5. It's all going to happen so fast that we want to make sure that anyone that comes in at any point can come along for the rest of the ride with us and then become so engaged that they will go back and look at those earlier stories. And the fact that we're seeing that same engagement every time we release out something new is just telling me that we're picking up more and more people and that people are coming along for the ride, and that's really exciting. That's one of my biggest hopes for this, and I think many of us have the same hope, is that this is that particularly for those of us that have never experienced this sort of thing before on the mission, it's like I really hope everyone else that has never had that opportunity before can come along too, because it's just such a cool experience.
The entire structure of the New Horizons mission, with it being a flyby and at such great speeds, is amazing and sort of astounding and scary to me, that it's just blows through the system, takes as many pictures as it can, it's offline, can't communicate during that period of time. It's collecting so much data, and then once it gets through, the connection when you're 4 billion miles away is not super fast. So you have to wait for the data to come in. Are there any data that you are particularly interested in receiving and knowing more about?
Yeah, there is, and there's the team that organizes basically how we do downlink, what gets prioritized. They've been really, it's been a really interesting process, because we had to do some restructuring after we had the SAFE event last week. So basically in that period, there was some time in which we could use to recover some of the data that didn't make it down during that period. And what's been prioritized has been a little bit different from what we expected. So over the last week, our schedule has been different than we planned. So we've been getting a lot more of the the spectral imagers data that's coming down. So this is the LISA instrument, and we're working with that today. And I don't think we quite expected to see as much of that as we did. But it also meant that we didn't see our new color images until they came down this afternoon, and we're working on those now. And the spectral cubes are showing some really fantastic. They're really the data that's coming in is really high quality, high signal to noise, and so we can really start to tease apart what the surface material is across the whole planet and across Charon. And going forward, how things go is that often we'll get a quick look version of a particular data set that's been compressed. So not all the information will be there, but a compressed and slightly degraded version of it will come down quickly, so we can get that and kind of know what to expect when we get the later, much larger file that has all of the information in it. I want to know, like I said earlier, that poll on Charon took us kind of by surprise, and I really want to understand whether or not that's some kind of a depositional feature. Does it indicate some kind of seasonal processes on Charon, which as best we can tell, compared to Pluto, which we've known for decades is a dynamic world. It has an atmosphere. The atmosphere's properties have been changing drastically since we first detected it in the 1980s to now. It's gone through spectacular variation, and we know that there have been global changes on Pluto. It's the planet's entire color has changed slightly. So there's all sorts of dynamic stuff going on Pluto, but as best we could tell, Charon's smaller. It shouldn't have held on to much of an atmosphere if ever. We've never detected one, certainly, and we've looked. So when the preconception going in is that Pluto would be the active world, it probably wouldn't be very heavily cratered because the surface would be young, geologically young, whereas Charon is probably an ancient surface that hasn't been restructured much, and so we'll have a much longer sort of integrated history of impacts on the surface. If we look at the dark pole on Charon and see that it is some kind of a depositional process has made it, and it's not like a crater or something like that, then that might hint at some kind of seasonal variations, and maybe Charon is a more dynamic world than we anticipated. I'm also really interested in understanding the cratering history in the system, and so I want to see the surface of Charon, which, even if it is an active world, it will likely be less active than Pluto, and so it will have a better record of cratering. And so one of the things that I'm particularly fascinated in as a Kuiper Belt, as a person who studied the Kuiper Belt throughout my career, is trying to understand how the object in the Kuiper Belt formed. And one of the best tracers of that process is the number of small Kuiper Belt objects, far too small to see directly. And so, like I mentioned earlier, there's this method of using serendipitous stellar occultations to see them, but that's challenging. And we have this wonderful record of craters preserved on Charon that allow us to see the record of much smaller impacts. And so we could try to understand how many small Kuiper Belt objects there are from that history of impacts, and from that try to understand the processes that formed planets at large distances from the sun. That will be fundamental to our understanding of planet formation across the universe.
So do you think that this is going to, New Horizons in general is going to give us good data that will help us understand the formation of the solar system?
Yeah, absolutely. So both the system, the data that we're getting back from the Pluto system, we've never seen a dwarf planet like Pluto up close before. We've certainly never seen a system like the Pluto system up close before. So trying to understand how the Pluto system formed and survived to the present day. There's a bit of a dichotomy, or maybe a paradox, you might say, in that the Pluto system represents, and that is that you need a large impact to form the Pluto system as we understand it. Basically, the process that formed the Pluto-Charon binary, and likely the small satellites as well, is very similar to the process that we think formed the Earth's moon. And that is that something maybe about the size of Pluto smacked Pluto early on, created a large disk of material from which Charon reaccreted, and then these small satellites formed further out. But the problem is that if you're in an environment in which an impact like that is likely, then you have impacts occurring all the time. So how do you keep these small satellites that have just formed in place? Or without just destroying them through further impact. So either you need to propose that there were many more small satellites in the past, and then you remove them all, and we're just left with the dregs, essentially, or you need to come up with some other explanation for the processes that form the system, or trying to understand, and maybe this is just the way to think about it, that rare events do happen, and so you might have to go to a relatively unsatisfactory answer of this is the one rare outcome, right, of this sort of thing. But we have reasons to think that that's not the case. It looks like many of these other large Kuiper Belt objects, like Eris and Quaoar, have experienced large mantle stripping collision events as well. So we think there's something going on there. and it's likely from the very early days of the solar system. So understanding that collisional environment will be really key to understanding how planets grow and evolve, and how our own moon formed in a similar sort of impact scenario. So there's a lot about just the fundamental processes of where planets come from that we can learn just from this one flyby in understanding this one system. And then beyond that, the idea of the extended mission and going to a Kuiper Belt object, the kind of Kuiper Belt object that we'll be flying by is known as a cold classical Kuiper Belt object. The Kuiper Belt has many subregions in it that have different dynamical properties and different compositional properties, and we know that much. And one of the most fascinating regions in my mind in the Kuiper Belt is this cold classical region. It's sort of when Kuiper and Edgeworth and others were first thinking about the Kuiper Belt, this is sort of the belt that they had in mind. It's beyond Pluto. It's very, very thin, dynamically cold, and that's where the cold classical comes from. So low inclinations, low eccentricities, very circular orbits. And objects in these sorts of orbits have distinct properties. They tend to be extremely red in color, and they tend to have a very different distribution of sizes. There tend to be far fewer large objects and small objects. They have much steeper distribution. And we think that they represent, based on the dynamics of the region, they represent the most primordial objects in the solar system. They're basically the remnant of the belt that the planets grew from that hasn't been jumbled up by the planets. So our asteroid belt, for example, has been through tons of collisional processing. Most of the asteroids that we see are members of collisional families. They're blown off chunks of other things. We think that many of the objects in the cold classical Kuiper Belt actually represent primordial chunks that dropped out of the solar nebula through some process. So if we fly by one of these cold classical Kuiper Belt objects, we're really looking, we think, at one of the primordial building blocks of the planets that hasn't been processed, hasn't gone through further accretion. And we really don't know what to expect in that. We've never seen something like that. Comets come from this region, but they've also been through lots of processing. And they're so small that they might represent collisional fragments. Whereas the bigger things that we're flying by that kind of sit logarithmically in between Pluto and a cometary nucleus, we think they're the fundamental building blocks. And so that will be really spectacular and really, really key to understanding where the solar system came from, where planets come from, and understanding our place in the universe.
That is fantastic, and that's really where your research came into this, and obviously a bit that you were very passionate about, and that I knew nothing about, which brings me to just a question that is more general. Is there anything that you think that we on SciShow should be talking about that people just don't know about, but is just fascinating and amazing about the universe?
About the universe,
or our solar system, or the universe.
How much time have you got? No, I think you guys are doing a really great job, and I've really enjoyed following the work that you're doing. And I think, I am so buzzing with the stuff that we're seeing on Pluto right now, and I know it's only going to get better as we start getting the information from closest flyby back. That I think that's all I can really think about right now. That's what's going on, and I think in a couple days' time, I'm going to have the things. These are the things, right, that we should be talking about right now, because we've never seen anything like this before. We've never seen anything quite like this particular kind of feature or this particular process on this surface, or we think we understand something fundamental about the solar system that we didn't even know to look for before. And that's the kind of thing that I think the flyby is really going to do. We're going to have those moments of, wow, we didn't even know to ask that question before now. And not only, have we asked it, but the answer is sitting there on a silver platter kind of thing. I'm sure we're going to have a few of those moments the next couple days and over the next couple months as the data, all of the data is coming back across this very slow link. Yeah, so just stay tuned.
All right. I know that you need to get back to your work. I do not want to keep you from doing it. And so thank you very much. This was absolutely a pleasure to have you joining us here on SciShow. Really cool to get some of your perspective.
It's fantastic to be here, and I just really hope that you guys are excited about this flyby as I am, because we're not going to see anything like this again for a very long time. And where we live, we're very privileged to live at a time like this, to see the first reconnaissance of the solar system completed. Great. So,
well, thank you very much. Thanks for joining us.
And thank you.
Thanks for joining us. Hope that you like this. A little bit more off the cuff and less polished than our normal SciShows, but I found it fascinating. If you liked it, let us know in the comments. Give it a like. And if you want to keep getting smarter with us, always you can go to youtube.com/SciShow and subscribe.